Here's another related rates example to add to your notebook. Hopefully right before this you had the ladder sliding down the wall. So this is just another example. We're going to talk about cars driving. Let's see if you can see that. So we have one car drives north and another car drives west from an intersection, the same intersection. All right. So that's just the setup of it. At the time the first vehicle is 3/10 of a mile north. It's going 20 miles an hour. It's going 20 mph. When the second vehicle is 4/10 of a mile west, it's going 25 miles per hour. At that very instant, when the first vehicle, that happens at the same time. The first car is 3/10 of a mile north, second is 4/10 of a mile west. At that moment, how fast are the two vehicles separating? I keep saying vehicles, but I mean cars. How fast are the two cars separating? Oh my God, I can't spell. SEPARATING. Question mark. All right, so there's our related rates question. We have a few different rates that we're given, and we have a few different distances that we're given. And what we need to do first is we need to draw a picture, because that's our first step with a related rates question. So let's set this thing up like this. And here's the intersection that the cars are driving from. So one car drives north. So he's coming up in this direction. And the other car drives west. So west is this way. And these distances are changing over time. Usually when we look at a picture like this, we can call this the y value and this the x value, and that's probably what we're going to do. And at the moment, the first car is 3/10 of a mile north. That's an instant in time. The second car is 4/10 of a mile west. And the speed is 20 miles per hour this way, 25 miles per hour this way. So what we need to do is find out how fast the two cars are separating. And what that means is, if this is car 1 and this is car 2, the distance between them is actually the hypotenuse of this right triangle right here. This is the distance that they're separating. So as they're driving away, this hypotenuse is growing and growing and growing. So the x is changing over time. The y is changing over time, and we can call this any letter that we want. We'll probably just call it z. So let's just set this up. X is changing, so we'll put that as a variable. That's not constant. This y value is also changing over time, so we'll just mark that as a variable y. And when they both change, this variable also changes. We'll call that z. And we're asked how fast are the two cars separating, so we're really being asked for the change in this z value over time. That's what we want. We're given the change in x over time. That's the speed of the first car. We're given the change in y over time. That's the speed of the second car. And so what we need to do is we need to set up these three variables, the relationship between these three variables. And so you can see, because this is a right triangle, it's just a Pythagorean theorem relationship. So we can set this up as x squared plus y squared equals z squared. Sorry about those bells. The next thing I want to list is all of the information that is given in the problem. So we are looking at the first car going 20 miles per hour. That's a rate. So that's dx dt is 20 miles in 1 hour. And it's positive because the x value is increasing as the car is going north. The y value is changing at 25 miles per hour, so that's dy dt, and that's also positive because the y value is changing. And what we want is dz dt. We want to find the change in z over time. And the other information that we're given is that x is 0.3 and y is 0.4. So x equals 0.3, y equals 0.4. And then step 4, I think it is, tells us to do the implicit derivative with respect to time. So taking the derivative, you get 2x dx dt plus 2y dy dt is equal to 2z dz dt, and that's what we want. Oh, the other thing that we need to find is the value of z when x and y are what they give us. So if x is equal to 0.3 and y is equal to 0.4, then we can calculate z with the Pythagorean theorem. 0.3 squared plus 0.4 squared is equal to z squared. And if you do the Pythagorean theorem and solve it for z, this is just a 3, 4, 5 triangle, and z is actually equal to 0.5. So that's the value that we're going to plug in into our formula. Z equals 0.5 at that moment in time. So let's just plug everything in at this point, and then we'll find out what dz dt is. So we have 2 times x times dx dt plus 2 times y times dy dt is equal to 2 times z times what we want, dz dt. I didn't give myself much space here. And so now it's just a matter of figuring out what these are. So when you do the math, when you multiply this out, and divide this by 2 times 0.5 is just 1. So actually all we're doing is multiplying those and adding them together. We will get dz dt to be equal to 32, and that is in miles per hour. And that's the end of that program. That's the end of that problem.